In this video, we are going to have a bit of a chat about looking for patterns in groups of numbers or in numerical problems and seeing if there's patterns or recurring themes that we can use to help try and solve those problems. Here's one for you. Sometimes they're real easy. Sometimes you've got to dig a lot deeper and use a few tricks and tips that we're going to show you as we go through this video. This one, not so hard. If you have a look at this, what is the pattern that you see in these numbers? Well, often a great strategy to try first of all is just to work out the difference between these numbers. And I can see that the difference between 1 and 4 is it goes up by 3. We add 3. Does that work for the next number? Yeah, if I add 3, I get to 7. And you'll see as I go along, if I just keep adding 3, I end up getting to the next number. So I would say the pattern there is that it goes up by 3. Not too hard with that one. What about this bunch of numbers here, or this sequence of numbers? Let's try the same thing. If I go 1 plus 4, oh, maybe this is the same. It goes up by 3, but if I have a look at the next one, 4 to 9 is an increase of 5. So my plus 3 pattern's not going to work here. And you'll see as I work my way along, the next ones go up by 7, these ones go up by 9, 11. And you kind of look at it and think, actually, there is a bit of a pattern there. Every time they go up, you'll see this is the next odd number. So I guess this one would be plus 13, which it happens to be. That's a pattern, but it's a bit hard one to put into words to say, oh, well, the first one goes up by 3, and then you just add the next odd number. Like technically it works, but is there something else that you notice about those numbers? 1, 4, 9, 16, 25. Do they ring any bells? Well, hopefully they do, because they are all square numbers, and they're all going up in increasing order. So 1 is 1 squared, 4 is 2 squared, 9 is 3 squared, 16 is 4 squared, etc., etc. So sometimes you've got to dig a little bit deeper if it's not just a straightforward increasing pattern, but then sometimes it even gets trickier still. Find the sum of all the integers from 1 to 100. Now, all that means is if you were to add up all of the whole numbers from 1 to 100, what would you get to? Now, you could start at 1, and you could put that in your calculator, and you could go plus 2, and then you could go plus 3, and you could do that in your calculator, but that'd be 100 times. Man, that'd be time consuming, and if you get one wrong, you'd have to start again. We're going to stop. We're not going to write out all of these numbers because it'd be way too many. So I'm just going to write out the first 5, and then I'm going to jump to the end and I'm going to write out the last 5 as well. And I'm going to see if I can find any patterns here that might help me to do this in a much easier way without going to my calculator and doing them all one by one. Have a look at the two outside numbers, the top and the bottom number. When I add them together, 101, I get 101. Let's look now, let's work our way in and look at the second and the second last number. When I add them together, what do I get? 99 and 2 gets me 101. I wonder if this pattern will keep going. Let's slide it in one more time for the third and the third last, and yeah, when I add them together, I can see that I also get 101, and that pattern will go on and on and on. So how many pairs of numbers are there? Well, if there's 100 numbers and I'm talking about pairs, there must be 50 pairs, because 50 lots of 2 will give me 100. So there are 50 pairs. So if I just take 101 and multiply that 50 times, because there are 50 pairs, I will get 101 times 50, which I could do with a pen and paper, or even in my head, I could partition that off and go, well, 50 times 100 is 5,000, and 50 times 1 is 50. So we managed to do all of that by finding a pattern without having to revert to our calculator or even a written algorithm. How about this one? Calculate this sum here. So I've got 25 minus 24 plus 23 minus 22. Hey, same deal. You could go to your calculator, punch it all in, and see what you get. But a much quicker, easier way, because I can see a pattern in those numbers. Can you see it? If I was to put brackets around each pair, starting at the front, I notice that each pair actually adds together to give me 1. Right? 25 minus 24 is 1. 23 minus 22 is 1. 21 minus 20 is 1. So by adding these brackets and just saying, look, do that bit, then do that bit, then do that bit, I can actually just realize that I don't have to add all of these together at all. Each of these pairs adds to 1. So if I just add all of those pairs together, but don't forget this 1 on the end is not part of a pair. It's sort of hanging out there on its own. So I need to include it as well. And I've got 1, 2, 3, 4, 5 plus another 15 gets me to 20. We found a pattern. We didn't need to put it in our calculator. Boom, and we got the answer. All right, good job. One more. This one's a bit different. We're going to model a problem here. Barry was so bored that he emptied his money box out and he lined up all the 5, 10, and 20-cent pieces across his bedroom floor. So it looked something like this, but it went right across the room. So the question we want to find answers to, what was the 21st coin and what was the 32nd coin in his row of coins? Now, I could write out 5, 10, 20, 5, 10, 20, 5, 10, 20, sort of 32 times, but it's probably quickly and easier just to model the pattern. The 5 cents will be the first, the fourth, the seventh. Right, so there's 1, 2, 3, 4, 5, 6, 7. I can see that that pattern is going up by 3. The tens will be one more on from that. So it'll be the second, 2, 3, 4, second, third, fourth, fifth, 6th, 7th, 8th. Once again, they're going up by 3 because there's 3 coins in the pattern. I'm going to take the 20s. I'm going to run this one right out. So I don't have to write out all of them now. I just have to write out the 20s. Okay, that will be the 3rd, 6th, 9th, 12th, etc., etc. So having a look here, what was the 21st coin? Well, looking at my pattern of 20-cent coins, I can see that the 21st coin was, in fact, a 20-cent piece. Looking at my pattern, since I could see that they're going up by 3 every time, I can just write out multiples of 3, and I can see that the 21st was a 20 cent. Now, the 32nd coin isn't on my list here, but I do know that the 31st coin, which was the one before, was a 20. So if the one before, the 31st, was a 20, the next one on is the 32nd. Following our pattern, it must be a 5-cent piece. Great job, guys. There was a number of different strategies and just tips for looking for patterns in numbers, and you might find different patterns altogether. Sometimes it's really straightforward. Sometimes you've got to dig a little bit more. Good job. Well done.